Sir, good evening. My name is Prakash. I work for Amrita School of Engineering, Bangalore. I am a professor in Mechanical Engineering Department, and I'm into the field of data science, machine learning since 2 3 years, and I'm handling different subjects in those area. So today, I've been I've chosen this topic: the decision trees explained like I am 10. This is the topic I have chosen. So I will be explaining a decision tree in a very simple and crisp way. So so what is a decision tree? So it is one of the ML algorithms which is helping us to predict based on features. It is very simple. We basically ask yes or no questions, then slowly build the tree, and finally we arrive at a decision. For example, here I shown a problem where we are supposed to make a decision to buy a home or not, and there are a lot of features involved, and we break and the features are like whether it is in the budget, whether it is location safe, whether it is close to our workplace, how many bedrooms, etc., etc., etc. The Depending upon the features, the tree may grow bigger and bigger. So first what we do is we make the feature break the features into smaller subsets by asking questions, and if the answer is yes, we proceed in one direction. If the answer is no, we proceed in direction until we arrive at the decision. This is in a nutshell what is decision tree. So decision tree, like, this is a sample data set I've taken. It is having multiple classes. So if you're not aware what is a class, so when in a machine learning problem, we have features and we have target, and the target is the output, particularly if you're dealing with supervised algorithm. So supervised algorithm has labels. The labels can be yes, no, red, blue, green, pass, fail, has disease, has not having disease, like that. So if you take this as a problem, there are two classes, this red and blue, and we have to make a decision whether it is blue or red depending upon the features. It could be any features. There's one target and there could be multiple features. Okay, so what decision tree is doing is, this data set is split into a smaller data set and smaller data set until we have a pure data set. So what is purity, what is impurity, all those things we are going to see in a couple of minutes. So our goal is like the decision tree is trying to make a pure data set. The idea is, if you choose a data point, what will be the nature of that data point, whether blue or red in this case. So depending upon problem, it may be differing. When it comes to a decision tree, there are some terminologies, simple terminologies that we need to uh, understand before we go into the actual machine learning algorithm. So this is the root node. Then we have branch. Okay. Then we have a leaf. This is a leaf. A leaf is something which is very pure. That means there is no. It is pure means only one class is existing. Impure means more than one class is existing. So that is a leaf node. So at each node we split the data. That's why it's splitting. And there is a branch at each node. Then you come to a leaf by following a path. For example, if you want to accept the offer, for example, if it is an interview, you want to accept the offer. So you start with salary, then vacation, then offers gym, yes, accept the offer. So we ask multiple questions at different stages, and basically the user should say yes, no, yes, no, yes, no, and finally take a decision. So this is called a path, and this one is another path, and if you take this route, that is another path, this is another path. So next is impurity. Impurity means the class at a particular node, how mixed it is, that is impurity. Tree depth, how many levels you want to go. Pruning means, in order to save computation time, we may stop at a particular, so instead of going to this level, we may stop at this level. So what is the tree depth? And overfitting, underfitting, concepts of ML, how good our model is working. So that is the terminology involved. So this is the flow in addition tree. So we have all data points. For example, we have data points of circles and triangles and prisms, etc., with different colors. So we split the data. And while before splitting, we measure the impurity. After splitting, we measure the impurity. Impurity, I will tell you what is impurity in a couple of minutes. Then after splitting, Okay, what is the impurity? So our goal is to reduce the impurity as much as possible. So until that we go in a loop. Then, so if it is a very exhaustive data set, we may go on and on and on. So we will have some checking conditions when we can stop the data set, or we have reached the efficiency at a certain level. So we can stop there. After stopping, the decision we have to take. This is the flow chart for our decision tree. Then very important concept in decision tree is impurity. What is this impurity? Like if you are trying to take a sample, okay, and that sample is having how many classes? If it is having only one class, for example, if you are dealing with pass fail of a student and you are taking multiple data points, all the students are pass, that's a pure. If some of the students are fail, it is a mix of pass and fail, then it is impure. So different ways of calculating this impurity are there. One is Gini index, very famously used. Another is entropy. For today's class or today's demo, I'm going to show you what is Gini impurity. Okay, so these are small things that we need to know before we actually go into the problem. So Gini impurity, again, it tells you how many classes are there. Okay, only thing we need to keep in mind, a pure node Gini will be 0. Impure node, highly impure node, the Gini index will be higher the value. Okay, the higher the value, higher the impurity. That means we cannot take a decision. The lower the value, the purity is high, it is easy to take a decision. That much is sufficient for today's thing. A simple calculation I've shown you. Okay, so for example, we have 10 data points and the data points are having yes class and no class. So originally, what is the impurity? So originally, how to calculate the impurity means here proportion. So out of 10 points, we have 4 positives, and out of 10 points, 6 negatives. So they are proportions subtracted from 1. That is the purity. So 0.48. If you have only 2 classes, the maximum impurity will be 0.5. There are some calculations and graphs which explain why it cannot go beyond 0.5. Of course, that is not, we are not going to deal that now. Later we'll see. Now, if all were 10 were yes or all were no, in either case, it is 10 by 10, that is 1. 1 minus 1 is 0. So that is very pure. What is the relevance of this impurity means? At each split, we are trying to reduce the impurity. That means we are trying to take a decision. Only when the impurity is very less, we can take the decision easily or confidently. That's the idea. I told you, the data set is going to be split into smaller splits. First, we have to find out the best split which minimizes the impurity. What is Gini index? One line is, if I randomly pick 2 samples, what is the probability they belong to different classes? If the probability is high, then both will be of different classes. If the probability is low, then it belongs to one class. Lower the Gini, purer is the node. So this is the fundamental idea of decision tree. So you have a data set here. I am showing you a data set. So this is a simple data set. I'll just go through it. So somebody loves popcorn, somebody loves soda, somebody loves age. Somebody has an age of some range. Okay, so what is this? The idea that this person will love a particular movie. Here it is called Cool as Ice is the movie name. So for a particular combination, will this person like this movie or not like this movie is this question. So we make the tree like this. We ask questions at different levels and we finally take a decision. So if any data point is given, so we are going to build a tree like this. So the first question asked here is whether he loves soda. Whether that question has to be asked, or whether he loves popcorn is the question to be asked, or what is the age is the first question to be asked, that we have to decide. That is secondary. Now this is how a tree will look like. So after building the tree like this, we are going to predict for something. So if this is the data point, this is a person, this person, will he love this movie or not? That is the idea. So here, so let us ask the first question, whether he loves the soda. Yes, he loves the soda. Then you go in this direction. False is not the answer. Yes is the answer because from the data set. So true. Then if true, then what is his age? Is it less than 12.5? No. his age is 15. So it is false. So he is going to like the movie. That is the conclusion. So for this data set, what will be this question mark? Yes, he loves the movie Cool as Ice. This is simple decision tree. A simple example. Now I will take, so I told you, right, when to stop this. See here I asked only two questions. Whether he loves the soda, what is his age, whether his age is less than 12.5. I have not asked other question. These two questions are sufficient to conclude whether the person is loving this movie or not. Now these are the, I told you now, when to stop. This tree can grow as long as it wants if the features are very high in number. So we have to stop a criteria in order to, so if you have reached a certain accuracy level, then we can stop. What is the stopping condition? This is theory, the theory behind how to stop. That we can, when we jump into ML algorithms, optimizing, hyperparameters, all those things, this we can go in depth. Now, to make it more under this concept clearer, I am going to take a example problem. What is the example problem means? Let us take this IPL match today, RCB versus LSG. Okay, so we have to decide something.
Royal Challengers Bengaluru are back to winning ways. They buried Mumbai Indians under a pile of runs at Wankhede.
RCB's highest ever score against the Mumbai Indians.
Now RCB host a wobbly Lucknow Super Giants, who were thumped by Gujarat Titans at home.
Just something to think about for the Lucknow Super Giants.
The two teams have a bit of history too, when tempers flared and emotions ran high. To add RCB's unbeaten home run hold, or will Lucknow spoil the host party?
So we have to, so here we have to make a decision who's going to win this match based on past data. So this is our machine learning pipeline. So we have these are the steps: data collection, data cleaning. So any machine learning algorithm, we have to go through this pipeline. Then we have to take the decision. So first thing is data collection, data cleaning and pre-processing, feature selection and engineering, train. These are the different steps. Okay, so all these steps we have to follow in decision tree also, or irrespective of what algorithm we are following, these are the steps. Because it is a classification algorithm, we have model evaluation also. Classification algorithm, and it comes under supervised algorithm. Okay, so a model evaluation, how this model is performing, that we should know. Then only we can go for deployment. If the model is not performing well, then we have to go for alternate algorithm. So I have taken the data from Wikipedia. Okay, so the data looks something like this. It has match number. Okay, it has who's playing against whom, whether it's home ground or not, who won. Okay, who won the toss, and whether he elected to field or not elected to field, like that. So much data is there. So I am going to take the data of 19 matches, okay, to decide on the today's 22nd match, okay, to tell whether this 22nd match who is going to win. So I am going to take 19. So this is this is a snapshot of the data which I have collected from this website. Okay, so just to give an idea of how the data will look like. So the data looks like this. When I just copy pasted it, then I'm using AI tools to clean this data and make it into structured data. You can see that this data is not it's sort of semi-structured data. It's not unstructured data, it's a semi-structured data, because we can easily extract data, make it in a form of a table. So I've used some AI tools to do that. Okay, so if you want to very carefully look at this problem and take the perfect decision, then you have to look at so many features in order to actually make a prediction. For example, this is some of the features. For example, which team, who are the opponent, which match number, date, which stage of the IPL it is, which venue they are playing, which city, whether home ground or neutral venue, day night match. So these are all the features. So this is another set of features. Okay, head to head, who is having head to head, who's having a much better win percentage, who are all the previous three opponents, what is the record against them. Then again, squad availability, target, psychological factors, then team strength, recent form, batting strength, etc, etc, etc. This is a huge, it becomes a huge data set with huge number of features. So we have to decide which feature we are going to take, how complex we are going to model it, all those things. Because this has to be told in for a very beginner kind of thing, I am making very few features. For example, who is the team, what is the opponent, who won the toss, what toss decision they made, whether it's home game or away game, previous match, just before this match, whether they won the
Uh,
loss. Yes,
Mr. Prakash, sorry
yes.
to interrupt. Could you please explain this in Kannada? Is it fine?
Yeah, I can do it.
Only this slide.
ಒಳ್ಳೆ ಓಕೆ. ಸೊ
Yeah.
ಇವಾಗ ನಾವ್ಗೆ ಆರ್ ಸಿ ಬಿ ಮತ್ತೆ ಎಲ್ ಎಸ್ ಜಿದು ಯಾರು ಇವತ್ತು ಗೆಲ್ತಾರೆ ನಾವು ನೋಡಬೇಕು. ಅದಕ್ಕೆ ನಾನು ಒಂದು ಸಿಂಪಲ್ ಆಗಿ ಒಂದು ಫೀಚರ್ಸ್ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿ ಇಟ್ಕೊಂಡಿದ್ದೀನಿ, ವಿಕಿಪೀಡಿಯಿಂದ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ದೀನಿ. ಅದು ಇವತ್ತು ಟೀಮ್ಗಳು ಯಾವ್ಯಾವ ಟೀಮು ಆಡ್ತಾ ಇದೆ. ಸೊ ಇವತ್ತು ಆರ್ ಸಿ ಬಿ ಮತ್ತೆ ಎಲ್ ಎಸ್ ಜಿ ಆಡ್ತಾ ಇದೆ. ಇವತ್ತು ಯಾರು ಟಾಸ್ ಗೆದ್ದಿರೋದು, ಆ ಟಾಸ್ ಅಲ್ಲಿ ಏನ್ ಡಿಸಿಷನ್ ತಗೊಂಡಿದ್ದಾರೆ, ಬೌಲ್ ಮಾಡ್ಬೇಕಾ ಇಲ್ಲ ಬ್ಯಾಟ್ ಮಾಡ್ಬೇಕಾ, ಏನ್ ಡಿಸಿಷನ್ ತಗೊಂಡಿದ್ದಾರೆ, ಇದು ಅವ್ರದ್ದು ಹೋಮ್ ಗ್ರೌಂಡಾ ಇಲ್ಲ ಅವೇ ಗ್ರೌಂಡಾ, ಮುಂಚೆ ಮ್ಯಾಚ್ ಅಲ್ಲಿ ಅವರು ಗೆದ್ದಿದ್ದಾರಾ ಇಲ್ಲ ಸೋಲ್ತಿದ್ದಾರಾ. ಓಕೆ, ಮತ್ತೆ ಇದು 19 ಮ್ಯಾಚ್ ಡೀಟೇಲ್ಸ್ ಇಲ್ಲಿ ಇದೆ. ಇದು 21 ನಾನು ಟೆಸ್ಟಿಂಗ್ ಪರ್ಪಸ್ಗಾಗಿ ಇಟ್ಟಿದ್ದೀನಿ. 19 ಇದನ್ನ ನಾವು ಟ್ರೈನಿಂಗ್ಗೋಸ್ಕರ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಅದರಲ್ಲಿ ರಿಸಲ್ಟ್ ಬೇಕು, ಯಾಕೆಂದ್ರೆ ಇದು ಸೂಪರ್ವೈಸ್ಡ್ ಅಲ್ಗಾರಿದಮ್ ಅಂತ ಲೇಬಲ್ ಇರುತ್ತೆ. ಏನ್ ಲೇಬಲ್ ಇಲ್ಲಿದೆ, ವಿನ್ ಲೂಸ್ ಇದೇ ಲೇಬಲ್. ಬೇರೆ ಪ್ರಾಬ್ಲಮ್ ತಗೊಂಡ್ರೆ ರೆಡ್ ಬ್ಲೂ ಗ್ರೀನ್ ಇರುತ್ತೆ, ಇಲ್ಲಾಂದ್ರೆ ಲೋ ಮೀಡಿಯಂ ಹೈ ಇರುತ್ತೆ, ಡಿಸೀಸ್ ಇದೆ ಇಲ್ಲ ಆ ತರ ನಿಮ್ಗೆ ಲೇಬಲ್ ಇರುತ್ತೆ. ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ರಿಸಲ್ಟ್ ವಿನ್ ಲಾಸ್ ಅಷ್ಟೇ ಇರೋದು. ಸೊ is it sufficient? Shall I go to the next one?
Yeah, we can continue.
Yeah. So now this data in the pipeline, if you see there is, after the data collection, we have done data pre-processing. So the data is something like this. So I showed you the notepad also how the data is. Then we have to go for pre-processing, because in pipeline we have feature selection, feature engine. I told you now, it's n number of features. If you want to real prediction, if you do it depends upon n number of features, but I've selected few depending upon the complexity and the audience that I'm having. Okay, so feature selection I have done. Then we have to split the data into train data and test data, because we should know our model whether it is performing properly or not. Okay, so I'm splitting the data. I have originally 21 data points. I'm splitting it to 19 data points. This is 19. Why I've taken this 19 also I'll tell you. This is 4 matches per team here. This 20th match and 21 is the 5th match of 2 different teams. So 19 data points are 4 matches. So it is approximately 25% of the matches. So which will be helpful for us to make the decision. That is this stage. What is that stage? That is train and test. So this percentage can be varied. In this problem I have taken like that, so that each team is having 4 matches. It's not the same in all the problems. It can be 80-20, it can be 70-30, it can be 50-50, depending upon problem, application, etc. Now, so I am splitting the model. Then after splitting the model, okay, this is very important feature. If you take this data, these are all in text. A computer does not understand this. This has to be coded. Okay, it's called as encoding. See, what this computer understands is zeros and ones or any numerical value. So even numerical value is converted into zeros and ones. That is a computer language. Now I am doing a simple coding. So toss win means a toss decision. Bowl means 0. Bat means 1. Home ground means 1. It is not home ground means 0. So last match result, if it is available and win means 1, if it is available loss means 0, not available is -1. Result means is win means 1, loss means 0. Very, very simple. So decision tree is one of the simple but very effectively used decision making algorithm, machine learning algorithm. Okay, now this data set, this is the data set, original data set. This has to be encoded before we are going into machine learning. This is the encoded. Okay, so you can see that 1, 2, 3, 4 columns I have encoded. It's very simple encoding, binary encoding. Okay, very, very simple. But do you think this is sufficient? No, this is not sufficient, because these 3 are in text. This also computer will not understand. But for demo purpose, I have kept this as text. This is I have encoded, but while giving into the machine learning algorithm, we have to encode this also. Okay, I will show you how to encode it. So for example, uh, so I have used Jupyter Notebook. I have taken the data here. So this is these are the different libraries that we use, and for each step in the machine learning pipeline, I am using different libraries and doing it. For example, for train and split, I have a library. Okay, for choosing which ML algorithm, I have a library and on a particular class. For doing encoding, I use a particular method. Okay, then after predicting the results, I have to compare the uh, accuracy of the model. So I use a library. Then for any plotting purpose, so finally in this decision tree, we are going to plot a decision tree. So for plotting, I'm using a plot. Okay, so because I'm not using the entire set for demo purpose, I have made a dictionary of the data that I have collected and then making a data frame. For making the data frame, I have the pandas library. So this is our data in the form of a dictionary, but it is not the case every time. We may directly read a CSV file or an Excel file or a JSON file, and accordingly we might convert into data frame and do it. So these are the next steps I told, right? So if you take this one, this is partially encoded, which is not correct. We have to completely encode it. For RCBV, RCB, KKR, RR, etc. We have to give some encoding. Then only we can proceed. So that is what is happening here. We are going to do the encoding. Then this is the entire data set for supervised algorithm. The last column here, or it's not the last column, one of the column is a target. So this is a target. Result is a target. It has labels. Okay, a target or label or output. It has classes. What are the classes? Two classes, 1 and 0. So this is our target or label. Okay, and the remaining everything are features. So what I've done here is splitting the data frame into two. One is the features, one is the target. I am making into two different data frames. So X and Y here are data frames, and one data frame is having the features and one data frame is having the target. Okay, after making that, we are splitting. I told you, right, in the beginning, we have to split the data into train data, test data. Of course, here 70% is going for training and 30% is going for testing. And random state is 42 because we want the same sample to come every time. Of course, this is useful when we are doing hyperparameters. As of now, you can take it that we have to use a particular random state, because we want the same samples every now and then when we are testing the we are training the model and going for testing. Then we are going to choose a particular machine learning algorithm. So there are different machine learning algorithm. One such is decision tree. So this is a class. I am making an instance of that class. Okay, so to that algorithm, I'm going to use my X train and Y train. That is what? Training data set. I'm going to use the training data set and fit the model. Once the fitting is done, I have to do the predicting. If you look at here, we are sending only X data, Y data is not sent because we are going to do prediction. Once you have done the prediction, we are going to compare the prediction with the actual results. So this is the actual results, Y test, then Y predict is the predicted thing. Then we have the confusion matrix, accuracy, R1 square, F1 square, or recall, precision, all those things. After predicting, we can compare how my model is performing. So here a simple run I have done, and it is the accuracy is 66%. Is not so good because our data set is very small data set. This is a typical decision tree. Okay, so depending, so this opponent less than 45. See what happens is, if you take look at this team opposition toss win, this text values will be encoded as 0 1 2 3 4. So it becomes a continuous value. That value we do some calculations and split. Okay, and we try to draw the tree. So this is the root node, this is the branch, this is the leaf, and you can see that we are stopping when the Gini index is 0. That means what? Pure. If you're picking a sample, it will be one particular class. What is the class? Here it is win, here it is loss, here it is win. But here, because the Gini index is having some value, it is a mixed. It is having both win and loss. So win is 5, loss is 2. I think here is loss is 2 and win is 2. Loss is 2 and win is 5. So to easily understand, I make another thing. This is a representative image. Representative. It's not the actual tree. If you run the code and the data which I have given, you are not going to get this tree, but it just represent how we are understanding how it works, the algorithm. So did the team win the last match? So if you take RCB, yes,
Mr. Prakash,
yes,
sorry to interrupt. So I think this is the last slide, right?
yes, last slide, yes.
So could you please explain this in the Tamil language? As you mentioned, you know Tamil as well. Are you comfortable with that?
Should I tell in Tamil?
Yeah, if you are comfortable with that, you can explain this slide in Tamil language.
Sure.
Yeah,
Okay.
thanks.
இந்த இமேஜ் என்னன்னா, இந்த இமேஜ் வந்து ஒரு ரெப்ரசன்டேட்டிவ் இமேஜ் தான். நம்ம ஏற்கனவே ஒரு டேட்டா பார்த்துருக்கோம். 19 மேட்சோட டேட்டா, யார் வின் பண்ணாங்க, யார் லூஸ் பண்ணாங்க, யார் ஆப்போனன்ட்டு, யார் ஹோஸ்ட் டீமு, அதெல்லாம் நம்ம பார்த்துருக்கோம். அந்த டேட்டாவை எடுத்து நீங்கள் டிசிஷன் ட்ரீ ஆல்காரிதமில் ரன் பண்ணீங்கன்னா உங்களுக்கு இந்த ரிசல்ட் கிடைக்காது. உங்களுக்கு என்ன ரிசல்ட் கிடைக்கும்னா இந்த ரிசல்ட் தான் கிடைக்கும். பட் ஈஸியர் அண்டர்ஸ்டாண்டிங்காக இங்கே ஒரு இமேஜ் நான் ஜென்ரேட் பண்ணி வச்சிருக்கேன். ஸோ இப்போ நம்ம ப்ரெடிக்ஷன் பண்ணணும் இல்லையா? இன்னைக்கு என்ன மேட்ச்? ஆர்சிபி வர்சஸ் எல்எஸ்ஜி மேட்ச். இந்த மேட்ச்சுக்கு நம்ம ப்ரெடிக்ஷன் பண்ணணும். அப்போ எப்படி இந்த அல்காரிதம் ஒர்க் ஆகுது? ஏற்கனவே 19 மேட்சோட டேட்டா வச்சு இந்த ட்ரீ வரைஞ்சிருவோம். இப்போ இருக்கிற டேட்டா பாயிண்ட், அதாவது ஆர்சிபி எல்எஸ்ஜி டேட்டா பாயிண்ட்டை வச்சு நம்ம பண்ண போறோம். ஸோ டிட் த டீம் வின் தியர் லாஸ்ட் மேட்ச்? ஃபார் எக்ஸாம்பிள் ஆர்சிபி எடுத்தோம்னா இன்னைக்கு அவங்க வின் பண்ணாங்க. ப்ரீவியஸ் மேட்ச் வின் பண்ணாங்களா தோத்தாங்களா? வின் பண்ணாங்க. ஸோ எஸ். ஸோ இந்த சைடு வந்துருவோம். தோத்தாங்கன்னா இந்த சைடு வரும். அப்போ எல்எஸ்ஜி போன மேட்ச் தோத்துட்டாங்க. அப்போ இங்கே போகணும். இப்போ நம்ம ஆர்சிபிக்கு வச்சு பண்ணுவோம். ஸோ ஆர்சிபிக்கு வச்சு பண்ணும்போது எஸ், அவங்க ஜெயிச்சுட்டாங்க, போன மேட்ச் ஜெயிச்சாங்க. அப்போ எஸ். அப்போ என்ன ஆகணும்? டேட்டா செட் அப்படியே கம்மியாயிரும். ஒரு ஃபில்டர் பண்ற மாதிரி தான். அப்போ பாதியா மாறிடுதுன்னு வச்சுக்கோங்க. அப்ராக்சிமேட்டா பாதியா மாறிடுதுன்னு வச்சுக்கோங்க. அப்ராக்சிமேட், பட் நாட் ஆல்வேஸ். யூ சி ஹியர், நீங்க இங்க பாத்தீங்கன்னா இங்க ஃபர்ஸ்ட் ஸ்பிளிட் பண்ணும்போது 13 சாம்பிள் இருந்துச்சு. அதை பிரிக்கும் போது இங்க 6 சாம்பிள் இருக்கு, இங்க 7 சாம்பிள் இருக்கு. இது பியூர் சாம்பிள், இது பியூர் இல்லாத சாம்பிள், இது இம்பியூர் சாம்பிள். இந்த 7 மறுபடியும் 5 ரெண்டா பிரியுது. அதே மாதிரி நம்ம 19 டேட்டா பாயிண்ட்ஸ் பிரியும் போது இதாயிரும். ஸோ எஸ், ஜெயிச்சிட்டாங்க. இப்ப இந்த டீம் எங்க விளையாடுறாங்க? சின்னசுவாமி ஸ்டேடியம். அவங்களுக்கு ஹோம் டீமா? ஸோ ஹோம் கிரவுண்டா இல்ல அவே கிரவுண்டா? இது ஹோம் கிரவுண்ட். ஸோ இது மறுபடியும் ஃபர்தரா பிரான்ச் அவுட் ஆகுது. ஸோ எஸ், அது ஹோம் கிரவுண்டு. ஸோ இங்க வந்துடும், இது வராது. ஸோ ஹோம் கிரவுண்ட்னா டிட் த டீம் சூஸ் டு போல்? ஸோ இன்னைக்கு டாஸ் வின் பண்ணது ஆர்சிபி தான். அவங்க இன்னைக்கு என்ன சூஸ் பண்ணாங்க? போல் பண்ணணும்னு சூஸ் பண்ணாங்க. ஸோ எஸ், தே சூஸ் இன்னைக்கு வந்து போலிங் போடணும்னு சூஸ் பண்ணிட்டாங்க. அப்படி இருக்கும் பட்சத்துல இன்னைக்கு அவங்க மோஸ்டா ஜெயிக்குவாங்க. சப்போஸ் அவங்க பேட்டிங் எடுக்காம பவுலிங் எடுக்காம பேட்டிங் எடுத்திருந்தாங்கன்னா தோக்கறதுக்கு அதிக வாய்ப்பு இருக்கு. ஸோ இப்போ சப்போஸ் எல்எஸ்ஜி எடுத்துட்டோம்னா எல்எஸ்ஜிக்கு போன மேட்ச் என்ன பண்ணாங்க? தோத்துட்டாங்க. ஸோ இங்கே வாங்க. ஸோ நோ. ஸோ இன்னைக்கு டாஸை ஜெயிச்சாங்களா இல்லையா? தோத்துட்டாங்க. அதனால நோ, இங்கே வாங்க. டாஸை தோத்துட்டாங்க. இன்னைக்கு ஹோம்ல விளையாடுறாங்களா இல்லையா? இல்ல, வெளி. ஸோ ரெண்டு சைடும் பார்த்தோம்னா மோஸ்டா இவங்க இன்னைக்கு தோக்க தான் போறாங்க அப்படின்னு இந்த ப்ரெடிக்ஷன். பட் நம்மளுக்கு தெரியாது. ஓகே, இது ஒரு சிம்பிள் எக்ஸாம்பிள் சொல்றேன். ஸோ ஹைலி டுடே ஆர்சிபி வில் வின் த மேட்ச். ஸோ தட்ஸ் அ வெரி சிம்பிள், ஒரு சிம்பிளான அண்டர்ஸ்டாண்டிங் ஆஃப் டிசிஷன் ட்ரீ. எப்படி ஒரு பெரிய டேட்டா செட்டை எடுத்து அதை எஸ் ஆர் நோ கொஸ்டின்ஸ் கேட்டு ஒரு டிசிஷன் அரைவ் பண்ண முடியும் அப்படிங்கிற ஒரு எக்ஸ்பிளனேஷன். ஸோ ஐ ஹோப் யூ அண்டர்ஸ்டுட். தேங்க்யூ.